Yeah, you're welcome. So we have David online. David
Yeah.
is the director of IIPGH, Institute of
Hi.
ICT Professionals. David, do you want to get us started?
Hello. Good evening.
Yeah. So you
You
have
are
you have the
welcome to
line.
our first webinar. And our resource person today is Emmanuel Asimadi. He is data scientist and is
Yeah.
going to take us through some introductory for those who have interest in data science. And he will take us around and give us some insight into what we should look out for.
Yeah.
So, Emmanuel, you're welcome, and we hope to enjoy ourselves in the next 1 hour. Thank you very much.
Yeah. Thank you very much. It's unfortunate I can't see you, but I see there are 17 people online already.
Yeah.
You should feel free. If you have any questions, remember you can put them in the comments and we'll address them as we go along. There will be time at the end of the session for questions and answers. So we'll try to address as many questions as possible. Okay, so there is room for any question, and we don't have any assumptions about your understanding of the subject area. So don't be intimidated by the kind of questions you think are good to ask. We will try and address all the questions. Now, for those questions that we are not able to address in the webinar, we would be sharing the slides with those questions addressed, and you can have a look at the slides together with the questions addressed as appropriately as possible. I think I'll use the opportunity to thank IIPGH, the Institute of ICT Professionals, for putting together this webinar. I think it's the first step in a very right direction, so to say, because the subject of data science is a significant subject everywhere around the world. I think when you look at the World Economic Forum ranking of top 10 jobs, data science is always in the top 5. And artificial intelligence is almost always a significant talking point everywhere around the world. Okay, so we know that countries are putting out plans for their various artificial intelligence policies. And for us to begin such a conversation, I think is a significant first step. And I think that this will not be the end of that step. We should continue to progress and have meaningful impact in the area of data science. As you see in the presentation, you are going to realize that I think in Africa, where the conversation is still not as mature as elsewhere, we stand to benefit even more if we take it seriously, because data science is all about deriving value from data and achieving efficiencies that are. So if you lack resources, you want to be efficient about the resources you are using. Okay, so it's an interesting subject area. Okay, so by the end of this session, I'm hoping that we are going to demystify the subject of data science, so much so that magic or that mysterious feel of the subject when we talk about it will almost vanish from your brains. Okay, I hear people talk about the subject area and it feels like it's magic. It's not always magic. That's one thing we want to be able to do by the end of this session. And by the end of this session, I also hope to structure your thinking around the subject of data science in a way that you can be able to identify your interest area and where you can play best in the subject area. Now, If we are not able to achieve anything at all, I'm hoping that we would have begun a significant journey. That will be almost like a revolution where you get to participate in the outreach programs of IIPGH to take the subject of data science and artificial intelligence to students in senior high schools, to students in JHS, because the subject area permeates every facet of our lives. If you talk of medicine, if you talk of literature, if you talk of even computer science, this is a subject area going to affect all those different dimensions of our lives. So if we challenge ourselves to prepare even the younger generations for this subject area, we stand to benefit and also minimize the divide between Africa and the developed world. Now, enough about me introducing the subject area. We'll go straight to the slides. Can you see my screen?
Yeah. Yes.
Good. Okay, so once again, you're most welcome. It's such a pleasure to host the first IIPGH webinar on getting started with data science. Hopefully, it won't be the last. My name is Emmanuel Asimadi. Okay, feel free to connect with me on LinkedIn, Asimadi. My specialization is in data science, and I've had, if you see my LinkedIn profile, I've had quite a varied portfolio. My specialization is in data science. Specifically, I'm currently working on projects in natural language processing that's interested in extracting meaning and insights from text. When I am not busy doing such intricate stuff, I like to go around running and raising funds for cancer, as you can see in my profile picture. I think particularly I have at heart raising funds for child cancer. And I am almost always committed to the work that Weswamo Child Cancer Foundation is doing in Ghana to bring child cancer to the forefront. It might interest you to know that child cancer is not on Ghana's NHS, but children stand to benefit when we put it on Ghana's NHS. And I think if you have the chance, you should all join the effort at making such requests to policymakers to put child cancer in addition to the other cancers that are already on the NHS. Now, what are we going to talk about today? Today, we shall be talking about data science. And by the end of the session, we are going to be discussing what data science is and what are the key enablers, almost going through the genealogy of data science and what has brought us this far, the key happenings or events in the timeline of just general data analytics. You may have noticed that data science or the analysis of data is an old trade. It is just in the last decade or so that the topic of data science has come up. And this can be attributed to very key events which we will discuss in the webinar, and will give you an appreciation of the sort of tasks that typical data scientists go through, and also a wide spectrum of job profiles that are available in the space. Secondly, we'll get to talk about why we should care about the subject of data science, because for the fact that we are talking about today, it means we seem to care about it, and we want to discuss why it is important. We'll show you some very interesting use cases that you could even will start to trigger your thinking around the subject, even in your workplace, and also think about how you can use data science for social good, because we have a lot of applications in social good. Then I think this is going to be the most interesting part for you guys, where we talk about opportunities in the space. A lot of the questions I get asked on LinkedIn, it's about how do I get started? What opportunities are there in the space? Do I need a degree, for example, to get started? And some of these questions will be addressed in this section. Then we talk about the careers, the learning paths, and I'll almost try to draw some kind of a technology stack that shows you where everything lies in the domain for you to almost, to say in a colloquial form, choose your poison. Okay, and then we'll have time for questions. Now, I need a timekeeper, so if I'm going beyond my timings, you will prompt me, David. And then if there are questions, yeah,
I'll prompt you.
Yeah, and if there are questions, please feel free to put it in the comments. Okay, so
yes, and then I'll read them out.
Exactly. Exactly. So for those who just joined us, please remember we are on a webinar, Data Science Getting Started, hosted by IIPGH. If you have any questions, remember to put them in the comment section. Okay, so what is data science or artificial intelligence? We want to keep the definition simple, and you'll be surprised at the definition we have here. Data science is the science of delivering value from data, deriving value from data. And if you leave this webinar without anything at all, I think you can go back with the fact that the whole subject and the whole noise you hear about data science is nothing more than deriving value from data. And the sophistications that go with it are just part of the process of deriving value from data. Now, if you take a more detailed definition on Wikipedia, for example, it says data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from data. There is also the definition by one of the tweets, the most famous tweet about who a data scientist is, by Josh Willis. It says that a data scientist is a person who is better at statistics than a software engineer, and better at software engineering than a statistician. Okay, so it's sort of the definition of who a data scientist is and the subject area is sometimes difficult to define, but we know for sure, just like what Josh puts out, that it involves some kind of software engineering or some kind of programming. But we know also that it's different from software engineering. We also know for sure it involves statistics, but we know it's not as thorough as what somebody who majors in statistics will practice. So it's not as detailed and as thorough as what a statistician will practice, for example. So in all of this, if I'll recap, you just need to understand that when we talk of data science, we are not doing anything extraordinary. We are only trying to extract value from data. And there are different levels of the values we can extract. Okay, so let's talk about why we have the subject area of data science. What are the happenings that have resulted in us reaching this state of needing this subject area of data science? Because in the past, we used to analyze data, and deriving value from data is not new. Data science came up only in the last decade. We are now trying to establish the motivations for the subject of data science. Now, if we take the genealogy sort of the genealogy of the subject area, we begin from the familiar grounds of where we had systems that were very simple and one monolithic database that you can query with your skills in SQL, for example. Okay, so sometime in the 90s and in the early 2000s, things were not as complex as they are now. We had BI systems, and if you needed to sort of increase the capacity of your database, you just got a bigger machine. Okay, so everything sits in one database, and you have nice tables, you have nice schemas that describe the tables. And if you want to query, you query one database, and the data is localized in one location. Okay, and the concept I think you should keep in mind here is what we call vertical scaling. Okay, in those times, if you needed to scale or if you needed more capacity, you just bought a bigger machine. And it's as simple as that. If you are storing 10 gig of data and querying it, and then in future you need 20 gig, you bought a bigger machine. And also one interesting thing in this era was that both data and the computing capacity to process the data almost always rested in the same machine. Then fast forward in early 2010. I hope you can see my slide animations.
No, the animations are not yet.
So in early, can you see horizontal scaling?
Not yet, yeah.
Yeah, so in the early part of the decade, somewhere 2010, some engineers from Yahoo, in building some search technology, developed the framework called Hadoop MapReduce. Now, if you have sort of read about the subject area, you would have come across this framework called Hadoop MapReduce. It used to be popular some time back. And there was also the notion of horizontal scaling. With horizontal scaling, when we need more capacity, instead of buying a bigger machine, we now introduce the concept of buying more smaller machines and processing the data in distributed ways, in a more distributed fashion. Okay, and you can easily start comparing and understanding why one approach is more scalable than the other. In the vertical scaling, assuming you keep growing infinitely, you will get to a time where you can't buy a bigger machine any longer. And then your growth stalls at that point. Okay, so the reason for the introduction of the concept of horizontal scaling is for us to almost buy what we call commodity machines and buy as many commodity machines as possible, depending on the size of data we want to process. And the processing of the data is what we is linear. Okay, so the cost or the speed of processing the data grows linearly according to how many machines you have. In this era, something interesting also happened as well. We tend to separate where we store the data from, how we compute the data or the resources used to compute the data. So you can think of it in a way that I can have a massive amount of data stored in a storage like Amazon S3. And then when I need it, I switch on machines, multiple machines, to do some computation on this data set. When I'm done with the computation, I switch off these machines. And then the data stays where it is. I don't lose the data. So that is the concept of separating computing from storage. And this enabled people to scale massively. Various businesses now can process large amounts of data that they couldn't process in the past. And you can now begin to start thinking of the complexities this introduces to processing data. So in the past, you would just write your SQL, but now data is stored massively in what we call a Hadoop cluster, an HDFS cluster, and you need to have some amount of programming background, like Java, to be able to query the data at scale. What was interesting in this approach also is that they are designed to resist failure, because now we are not dealing with a big machine that has all the strength or the capacity. When we do horizontal scaling, or the concept of map reduce, we know that we are dealing with commodity machines that are liable to fail. So we plan for their failure by replicating data. And so when one machine fails, we almost can recompute the processes and come back to where we were before it failed. And there was a concept of cloud computing. David, I can get feedback. There was a concept of cloud computing pioneered by Amazon, where I can switch on machines in the cloud. So you can sit in Ghana and switch on machines that your salary cannot afford to buy, even in a year. You can just switch them on and use them for an hour and be able to pay for it. It's more like the concept of renting a big machine and using it for the computation you want to use it for, and then switching it off after using it. Now, this enabled even small companies to now compete and almost process very large amounts of data. The cloud also enabled us to store massive amounts of data. And that leads to the concept of big data, which you might have heard many times. So the concept of big data starts coming up in this era where we have cloud computing. Now you can store massive amounts of data in the cloud, and it's quite cheap. It's very cheap to store on Amazon S3. Microsoft has its own storage facility called, I think, the Blob Store. Google also has its cloud storage solution. So they all provide cheap storage. And now anything that can be measured is measured and stored. You can think of people putting around IoT devices like temperature sensors, humidity sensors, different measurement. You can think of the YouTube videos that we get uploaded from time to time, Facebook, Twitter, all these various data sets just came up in the last decade, and they are massive, and we get to store them and analyze them. And this led to the concept of big data. Now, the characteristics of big data, one of the popular characterization and definition of big data qualifies it with 3 key V's. We call it 3 V's. Some people talk about it in terms of 5 V's. We talk about volume, the fact that the data has volume. You can talk about satellite images. You can talk about social media videos. You can talk about images and stuff like that. So data has volume. Big data has velocity. So sometimes you have data coming in real time and you need to process it in real time. And then the most important One which also adds to the complexity of the field is the fact that the data is now varied. Okay, so there's a lot of variety. Now, people store files, others store in JSON format, others store it in tabular format, and they want to process all of this at the same time and derive value from the data. The subject area is such that we do not want to limit people on what kind of data they can process. Once they have stored the data, there should be systems, there should be frameworks that allow you to process the data. And all of this are stacking up to the complexity that has resulted in a science that is geared towards deriving value from data, which is data science. And there is also a very important concept of web services, what we call, some people call it REST APIs. This allows us to package applications and expose them nicely for people to call. Okay, so a lot of these cloud providers now, when they build sophisticated algorithms, they can allow you to call it using a simple URL, like an HTTP request. So for example, if you go on Microsoft Azure's webpage, for example, and you wanted to do sentiment analysis of a body of text, you can just type the text in some tiny box and then click submit. And then it calls this API, behind which is some algorithm that tells you whether the sentence you have typed is positive or negative and the key entities in that sentence. Now, this is a significant enabler because it means that you can build an algorithm yourself, okay, find something interesting and build some kind of algorithm or data analysis structure and host it in the cloud and just expose the endpoints for people to call nicely. So assuming I build a chain for those in telecom, for example, assuming I build a chain prediction algorithm. Chain prediction is about predicting whether your customer is going to leave you or not renew your service. By collecting historical data, we are able to predict that a customer can churn. Okay, assuming you have some fancy algorithm that can predict this, you can package it nicely and put it in Azure, for example, and expose it as a web service or a REST API. When you do this,
we've done 30 minutes, so we need to move a bit faster.
Yeah, thank you. So when we do this, we can almost call this REST service in Excel, for example, and ordinary people who don't even need to care about how you did your model can use the model. So this approach allows us to almost share data between different applications. Okay, all of these complexities have resulted in data science as a subject area to sort of formalize the practices around deriving value from data. And I've captured in this some of the key frameworks, like there is Apache Spark, which we'll talk about later. There is machine learning. There is the concept of deep learning. These are just examples of some of the things that have been enabled by these different events that happened in the last decade. Okay, so there are a number of things that come to mind when you talk about artificial intelligence. A lot of the news out there sort of use the terms interchangeably. Here, I am hoping that with these slides, we get to put into context what artificial intelligence is in relation to machine learning in relation to deep learning and almost see the history of all of this. Okay. The most important point here is that artificial intelligence is a wider and bigger branch of trying to make machines as intelligent as humans or even better. Okay. Then came a period of in the 1980s where we we are dealing with a smaller subset of algorithms, statistical approaches uh, that try to help machines to learn from experience. You give them historical data and they try to predict the future or try to predict the unknown data. This concept is what we call machine learning. And I'll explain a bit more about this later. So machine learning is a subset of artificial intelligence. Then we have the newest concept, which is quite noisy currently. That's the area of deep learning. It's a subset of machine learning, but it focuses on using a special kind of um, algorithm, which mimics how the brain works. We call them neural networks. And they are essentially creating more sophisticated functions than what you typically see in machine learning. But because they are able to create more sophisticated functions, they are better at predicting outcomes or solving complex problems. The key enablers of deep learning are two things. The fact that we have a lot of data. We have been able to aggregate a lot of data in the past few years to train our deep learning models. And the fact that we have the significant computing power required to train deep learning models, all enabled by cloud computing. So deep learning and the concept of deep learning existed long before, but they have now resurfaced because we have now gotten enough data to train the models, and we have gotten enough capacity in terms of computing capacity to train the model. There are some significant breakthroughs in deep learning in terms of image recognition, text translation, for example, and other interesting use cases. I think if you use credit cards, for example, there is the feature where you can almost take a picture of your credit card and the numbers on the card pop into the form that you are filling automatically, so you don't have to key them in yourself. There is also this nice feature about Google Photos where you take pictures, and these days we take a lot of pictures, and you can now search those pictures with text. So you take a picture of a sunflower, for example, 20 years ago, and then you can now search, type sunflower, and Google will bring up the result of a sunflower on your phone that you took a couple of years back. So these are being enabled by deep learning. Now, let's get familiar with the concept of machine learning. I think we are already familiar with machine learning, but unfortunately, some of us don't know we are already familiar with it. So take, for example, I give you the input X, and I say that the input X is 1, and it maps onto 3. Okay? And I tell you that there is another input 2. Okay? 2 maps onto 5. I'm trying to have you think about the process this 2 goes into to be able to map onto 5. Now, if I give you 4 and I tell you 4 maps onto 9, can anybody tell me what 5 will map onto? If you follow, just type the answer in the box in the comment. Is anybody able to tell me what 5 will map onto, given that 1 maps to 3, 2 maps to 5,
So
4
somebody,
maps to
somebody,
9?
somebody said 11.
Somebody said 11. Okay, thank you. So 5 maps onto 11. That's nice. How did you come by that?
Well, somebody said 14, somebody said 14. And so,
Somebody said 14. Okay.
yeah.
Yeah. So let's start with the person who said 11. Is he able to
Okay,
tell us how he came by that?
so that's Chinedu. Can you tell us how you came about 11? Is Chinedu there? Can you tell us how you came about 11?
Yeah. So, okay, so I'll continue from there. But 11 is an interesting answer, and I think is the answer. If Chinedu had a mic, he would have told us that I'm just multiplying x
He
by
said,
2.
he said he added 2 to 9.
Okay. Yeah, that's another way to do it. Yeah. Okay, so the objective of this is that I'm looking for what process I'm doing in the middle to arrive at y. Okay. What I have done is just to multiply x by 2 and add 1 to it. So 2 times 2 is 4 plus 1 is 5. 2 times 4 is 8 plus 1 is 9. 2 times 5 is 10 plus 1 is 11. Okay, this is what we have done in primary school. If we have we have done a lot of this in primary school,
Yeah,
where we sort of try to find an equation or fill in the blank spaces. Okay,
yeah,
and it's very typical of what we are training machines to do. We give them
yeah.
historical data, and we try to ask them to tell us something about the unknown. Okay, and what the machines are doing is just to find that function that's the transformation. Okay, in
Yeah,
this case, that function is 2x plus 1.
yeah.
So when somebody tells you they are building a machine learning model, for a lot of the time we are just trying to find this function that is best at mapping a set of inputs to an output.
Mm.
Yeah. So this is a typical what we call linear regression function. It is just a straight line. There could be more sophisticated functions at predicting the output given the input.
Yeah.
There are also other classes of machine learning algorithms that are classifying using trees and stuff like that. But you just should understand that when we are talking about building a model, and especially in a supervised way, we are just looking for this function. And it's as simple as that. Now, to bring this down to earth, you can think of X as assuming we want to predict the price of a car. Now, the
Mm.
X is no longer a single value like 1. The X could be the make of the car and then the age of the car. So given the make of the car and the age of the car, we want to predict the price of the car. We'll give the model a set of historical prices. And then when we have a new make and then another age that we don't know the price of, the model will predict it for us. And all the model is doing, like we have seen previously, is just to find a function in between.
Time check, 40 minutes.
How many?
We have done 40 minutes, have to move a bit faster.
Okay. So why should we care about this? This is enabling a new paradigm. In the past, we have been thinking of data as a cost center. Data is no longer a cost center. It is an asset in the sense that you can almost monetize in new revenue streams. An example of, say, MTTU. They probably have video cameras. That's a motor traffic unit. They probably have cameras in Accra or in the cities. At present, they are using those videos, which is data, to run their operations. And they can think of it as cost, which is the traditional way of thinking of it. But if you think of it as an asset, you can then begin to think of what can I do with this data asset to sort of monetize it. And such a data can almost be converted, anonymized into counts of vehicles that pass a certain junction at any time t. And that data, if it is exposed nicely, is an interesting data for somebody in marketing, for example, to know how to position their signboard and stuff like that. Data is also a differentiator of your service quality. If you maximize the value you derive from data, it sort of differentiates the service quality that you can give your customers, or it becomes a differentiator. Then
basically, having data gives you enough information to be able to improve on your services.
exactly. Yeah. Then you can also say that data creates a barrier to entry. If you take advantage of it, you can create a business. Let's take YouTube, for example. Anybody can create a video sharing site. Okay. But the fact that YouTube has data and is able to maximize the use of its data and also make recommendations to users with the current data it has, it sort of now creates a new barrier to entry for their competition. So in the traditional sense of thinking of data as a cost center, you sort of lose sight of the fact that data is an asset and can almost be something you look at to stand apart from your competition or create a barrier to entry for your competition. Now you can also, I hope you can see my slide.
You can see, yeah, you can see.
Yeah, so here I'm trying to capture the spectrum or the maturity of your data analysis capability of organizations. Okay, a lot of the time we a lot of organizations are usually at the lower two levels. So when you move from the left to right, there is increasing complexity and there is more value. The first stage is descriptive. It just talks about what happened. So these are typically building reports. The second stage is trying to understand why it happened. Why did it happen? Those are the diagnostic kind of analysis. Then when you go higher, you talk about predictive. So you try to predict what will happen next.
Yeah.
Then the final stage is the prescriptive, sort of what should I do? So by this, you can almost assess.
When you predict,
Again,
then you can then decide what you have to do in order to take advantage of the situation or rectify a problem.
Yep.
Is that what you mean? We understand the descriptive, the diagnostic, but between the predictive and the prescriptive,
Prescriptive. Yeah.
can you explain that a bit?
Yeah. So for predictive, you try to predict. The typical use case is maybe churn prediction. You have your typical customer data. You can decide to find out why they left. That is diagnostic. But when you start using the data to predict that a certain customer will leave you before they leave you, you have entered the predictive phase.
Okay.
So if you can predict accurately that this customer will leave you, you will put in campaigns and measures to prevent them from leaving you because you know the acquisition
You are
cost.
prescribing a solution to it.
Yeah, so you predict, and then in the end, you prescribe a solution.
Okay, great.
Yeah, so you can see I have a lineup of some of the use cases. So typically, if you can think of preventive maintenance. In the use case of preventive maintenance, we have a schedule. Every 3 months, we visit, we take our car for oil change.
Yeah.
That is the basic one. Whether we have used it enough or we haven't, we tend to say, okay, every 3 months, let's go for oil change. If we are thinking in the predictive realm, we'll probably fit a certain IoT device to the car that measures how well the engine is combusting. And then when that triggers, then we know we have to go for oil change.
Yeah.
That means that you are possibly going to do less oil changes in a year,
Yeah.
or you are going to be safer in doing your oil changes. The timing of your oil changes will be right. It could save you cost. And it's a more advanced analytic of your data. Now, when you go into prescriptive, they are almost prescribing solution. So these systems almost take your data, process it, and then almost automate the solution. So in this area, you can think of recommendation, where when a user browses the internet or browses a site like Amazon, we can recommend to them what else they should buy
Yeah.
and stuff like that. Now, I think to almost cement these stages, I've tried to put the job profiles at the various stages. So a job profile like the traditional analyst, BI developer, visualization expert are usually in the diagnostic stage. They are trying to just report on the data. They are trying to understand what happened in the past. When you get into the data science, the machine learning sphere, you typically want to predict, you want to understand the data in more complex ways and almost prescribe solutions. So they are in the right side of the analytic spectrum.
So, meaning if today I want to be a data analyst, I'm
Yeah.
actually in the diagnostic
Yes.
domain.
Yeah. So you'll be mostly in the diagnostic domain, but these things are spectrums.
Yeah.
It is easy these days for an analyst to almost plug and play a machine learning model by knowing just the inputs and the outputs and understanding how to evaluate the model.
Yeah.
Yeah. So
So, for optimization engineer, this person is actually doing the prescriptive, basically providing a
yes,
solution.
exactly. So this person is almost like a domain expert in the in that field. They have this unique knowledge. In the prescriptive field, you're almost simulating. You are doing, if you have almost come across this concept of linear programming,
Yeah.
you almost box the problem in a set of lines and know that when you do A, your chances of succeeding are best.
Yeah.
And so you go with A because you know that the probability of A giving you the best outcome is good.
It's high. Yeah. Okay.
Yeah, it's high, yes. So you
Thank
can
check.
so you can almost situate your business in this map and try to grow your capability further to the right. And you derive more value from the data by participating further to the right. There are other use cases. Google says by looking at your retina, we can predict your risks of heart attack. There is also the use case in agriculture, which is very interesting for us as well, where we sort of can efficiently use water resources if we can sense the amount of water in the soil. A typical IoT use case, the amount of fertilizer and moisture in the soil, to know when to fertilize and know when to water, for example. And this all are interesting use cases that have been enabled by the area of data science.
So in this
I'll
in this
stop
case,
here.
this can be applied to all the fields.
Yes, exactly.
Journalism, agriculture, literature,
Yeah,
medicine.
yeah, even journalism, where you think that is a traditional literature subject, data science finds application in those spaces quite strongly. So it passes
So
almost all the.
Samuel Adreni said that we have a use case that determines fraud transactions.
Exactly, yes. That use case is called anomaly detection.
Okay.
Yeah. Now I'll pause here because we have run out of time.
No, let's continue.
Okay. So we talk of the career paths, um, which I'm hoping will take a lot of your interest. So here I have sort of put together some summary from Data Science Central. So what you see here are the different opportunities and the job roles that exist in the space. You have a data scientist, you have a machine learning engineer, you have data engineer, blah, blah, blah. And I know some people need to see to believe. So
Yes.
I've decided to take a screenshot
It
of
is called seeing, it is called seeing is believing.
I've decided to take some screenshots of my LinkedIn page, and you see here head of machine learning, 150 pounds per annum. The skill set is Python, Scala, and Apache Spark. And then you see all other ones. The field of data science in the last decade has been classified as the sexiest job in recent times. And the
Okay.
demand is quite high. I also think that you'll be asking me why these jobs are not available in Ghana or Africa, for example. But
Can you
this,
explain why?
yeah, this, I think one, our system has not matured enough in storing the data and sort of deriving the significant value we ought to derive from the data. We are still at the bottom of, if there is a Maslow uh, theory of needs in data science, the first stage is getting the right amount of data before
Yeah.
you can even apply some of these things on it.
Yeah.
And generally, the field is still in its infancy and everybody is still trying to figure out how to do stuff.
So in your previous slide, you said that people can earn between 70, 80,000 US dollars to 100,000 US dollars per annum.
Yeah.
So are those jobs in only in Europe or in
Yeah. A
America
lot of
or
these jobs you can see here, London based. There's a lot of them in US and then in Europe.
can
Okay.
people also sit in Ghana, for example, and still work for such organizations and earn such
Exactly.
amounts?
Exactly. So the the concept of cloud computing is what enables this kind of things. So you can see it in Ghana and switch on machines in Amazon in the US and process data. And there
Okay.
is
So
nothing limiting you except you having a normal internet connection into the cloud.
okay. There's a
So
question here whether data science can be used in the healthcare industry, for example, healthcare insurance.
yeah, it finds application anywhere you have data and anywhere you have questions to answer about the data. So if you have questions to ask this data, you are in a good place. In healthcare, like I told you, you look at Amazon telling us, you look at Google telling us that from your eye scan, we can predict the fact that you are at risk of heart disease. It's so significant. And it is just the image of your eye that we are using to do this prediction. We are going to almost like take, if we want to build such a model, we just need images.
Okay, so there's a question that which of the four domains you've mentioned, which four technical skills does one need to be called a data scientist?
Okay, so I'll show that in this slide. Now, in this slide, I'm looking at the job profiles. Okay, what is interesting, let's look at it this way on a spectrum of from the business problem, somebody who is close to the business in terms of the business problem definition and stuff like that is on your left. And then you go all the way to production, putting a system live with the Linux stuff or the operating system stuff and database stuff, and then having people to use it on your extreme right. If you have that spectrum, this is how we can attempt to line up the different roles. Okay, so you have
Okay.
your domain expert to the left. There is the business analyst who usually will interact with the domain expert to understand the business problem and do some basic analysis. Those who visualize are there. Those who do BI developers, they program or configure your reports so that the analyst can run and understand the trends and do those diagnoses we talk about. Then we also have now the new fields of data science. These are people who take massive amount of data and try to play in the area of prediction, prescriptive, and doing more sophisticated analysis with the data, not just running basic queries about the data.
Okay.
You have the area of the data architect. Now, because we are dealing with distributed data and data that is big, the infrastructure that we set up is also not trivial. Okay, some use cases are streaming data almost in milliseconds, large amounts of data in milliseconds. Some use cases want to take decisions on the stream of data as it is passing the network. And some want to do it batch. Others want to store the data in case 5 years down the line, they find a use case for it and they want to use it. So the data architect is responsible for setting up the infrastructure for that. The data engineer is a more complex role. And as you can see, he is closer to production than the data scientist. Yeah, so he is almost taking the model or the proof of concept from the data scientist and putting it live in production.
Okay.
Making sure that if there are 10,000 requests to the model scales well enough to accept those requests.
Okay.
Yeah, and now if you look at the skill set, I've just shared that in the slide. You should now see the skill set moving from the business problem to production.
Yeah.
And I try to treat all these things as spectrums because as humans, our interest is not boxed.
Yes.
Okay, so you can have a data scientist who could almost double as a data engineer.
Yeah.
Or in an organization that is small, you don't want to have a data scientist and a data engineer, for example. Yeah, so it's trying to understand that this humans cannot be boxed and it is more of a spectrum.
Yeah.
Yeah, so you have the typical skills for the analyst is SQL. The programming languages are Python, R, and Scala. Python is the strongest, at least in recent times, in the research that I have seen so far. Python is the strongest.
If I want to become a data engineer or, for example, a data architect,
Scientist. Yeah,
I
okay.
think that I need to have Python before I even start.
Yeah, so you need the programming background that's significant. But as an architect, you need to know all the boxes that offer the solutions you need. So as an architect, you are typically not even into the programming of it, but you need to know the concept that if I want to fulfill a streaming use case, I need to switch on a streaming box and it should have this dimension. I need to switch on a storage box somewhere. I need to switch on another box for visualization and stuff like that. You need to know all the boxes that lend themselves to the solution and be able to stitch them together.
Mm.
Yeah. But as a scientist, somebody who is close to the business outcome and analyzing the data, programming in Python is interesting.
Okay.
Yeah, SQL is almost running through all of them because SQL, uh,
Somebody's asking whether VB is not okay.
which one?
VB, Visual
Visual
Basic.
Basic. Is that Visual Basic?
Yes.
Yeah. So I won't say a programming language is not okay, but if if you look at the sort of problems you want to solve, um, the language should be mature enough with the components you need to solve it, so that you don't play uh, at a level of trying to do the plumbing, the basic
Mm.
plumbing work.
Mm.
Yeah, if you become unproductive if you have to do some plumbing work to get value from the data.
Okay.
So these languages like Python, R, and Scala have libraries and data structures that allow you to process massive data. Now, if
Okay.
VB does not have it, you don't have any business in VB.
Okay.
Yeah,
For somebody who has a limitation in programming and
yeah,
wants to stick to, say, being a, a visualization aspect, do you
yeah.
still need Python or SQL is enough?
Yeah, SQL is quite enough, especially for most of the visualizations that you see here. You have Tableau, you have Click, and this is not an exhaustive list. You have also Power BI. They are
Okay.
almost like a drag and drop with a kind of Excel feel.
Okay.
The kind of programming you do will be to do a formula or a
Okay.
calculation field here and there. But a
Yeah.
lot of these things are now quite easy to learn. Now, if you
Okay.
have an
What
IT
about
back,
Power BI?
pardon?
So somebody also recommend SQL, Tableau, and Power BI.
Yeah, Power BI.
Yeah.
Yeah, Power BI is Microsoft's solution for visualization.
Okay.
Yeah. So a lot of these things, if you have a programming background, you will not find it difficult to program in R or learn to program in Python or learn
Okay.
to program in Scala, for example. They are
Okay.
all functional and they tend to allow you to do things quite easily because
Yeah.
they know that developer productivity is important. So they
Mm.
try to build the libraries according to that.
Mm.
Uh, One most important one in the area is Apache Spark.
Mm.
If you are talking big data, uh, a lot of it revolves around Apache Spark. And a lot of the time, I argue that Apache Spark is the entry point for big data. And why I say this is that the framework is a unified framework for processing big data. And
Mm.
the concept of it is for you to be able to do any sort of use case in one platform and also connect to multiple data sources. So
Mm.
you can connect to JSON, CSV, Parquet, connect to text files, and bring them all into your analysis.
Okay.
Now, this platform supports R, it supports Scala, and it supports Python. So when
Okay.
you want to program on this platform, you can use any of these three languages of your choice. Sorry, I didn't mention Java, but I'm not interested in mentioning Java when we talk about data analysis. If you are a Java person, you the structures are similar to what you have in Scala, only they
Mm.
are much more precise and cleaner.
So it's recommended you take Scala since
Yeah,
that
you
is.
use Scala, and Scala is nice when you are programming in Spark. You you write your code and it looks like English.
Yeah.
Yeah. Okay. So, are there any more questions? How much more
No.
time do we have?
So someone is saying that someone Adreni is saying that you didn't like Java in school, so you didn't want to talk about it.
Yeah, so I think in this space, when you look at the programming, the length of code, Java
Yeah,
feels a bit verbose. And
yeah,
you have to understand that in programming against data, you are not
yeah,
building a software,
yeah.
essentially. You are almost trying to analyze and derive value from data. And how
Yes,
quickly you get to that value is important.
yes.
Yeah. Then I'm trying to show you here, you should have the slide now. I'm trying to show you here the technology stack. Okay. By showing you the technology stack, I hope that you can understand where everything sits
Yeah.
and which parts might interest you.
Okay.
Okay, so going from left to right is from data source
Okay.
to where we consume the data
Yeah.
and the various technologies that can be at play in
Yeah.
between.
Yeah.
Okay, so you understand that we collect the data, we store the data, we can analyze the data, and then we can consume the data.
Yeah.
Okay, so the typical types of data that we collect are logs, application data. There is also sensor data, which is the IoT use case.
Okay.
Yeah, and that IoT,
Let me just take you back. There's a question here. Somebody wants to know what you would recommend based on your experience for someone who wants to do to go deeper into data science, maybe want to do deep learning, maybe.
yeah, so yes, there is always going to be a starting point. A lot of the deep learning libraries are in Python.
Okay.
And Python, sorry, deep learning is almost at the bleeding edge of machine learning.
Mm,
There are, we are still forming the sort of valuable use cases you can get with deep learning.
mm,
The examples are the driverless cars. The examples are the image recognition. The examples are text translation. Okay. I can assure you also that a lot of the problems we have are also solvable by just generic machine learning algorithms or generic machine learning. Okay. So
mm.
if you want to go into that space, you need to be familiar with Python and the data structures in Python. There is no rule that says that you should learn machine learning before you learn deep learning. But
Mm.
I think it is advisable to get a grasp of some of these concepts before you go into the deep end.
So what question here? Recap the difference between structured and unstructured data
Yeah.
with some practical examples.
Yeah. So structured data is typically data that is very well structured in a table like
Mm,
Excel.
mm,
It has a very nice table and there is a nice schema on top of the data.
mm,
Yeah. Tables are nice, but relational databases don't scale. You can't grow massively with relational databases.
mm,
Now we are having the likes of Google Spanner trying to do stuff like that. But if you store data in relational databases and you also want to keep the consistency of joining data and stuff like that, you will never scale.
mm,
Uh, Now we come to the concept of unstructured data or semi-structured data.
mm.
They are the category of data that is almost stored in what we call key value stores or JSON. You can see it as JSON. You have the attribute and then the value. That is
Yeah.
semi-structured. And sometimes some keys can get missing, but you are supposed to be able to overcome that problem.
Mm.
Okay. Also,
Yeah.
in unstructured data, the best unstructured data you can think about can be text or video.
Yeah.
They don't have any structure at all. There is no schema. And
Yeah. So
you can
emails, images, videos.
exactly you can imagine me giving you a body of text like Akufo-Addo's speech and telling you to write a program that extracts the name of uh, towns in that speech.
Yeah.
It's not as easy as writing SQL to query a table.
Exactly.
Yeah, so when you are moving into unstructured, the complexity is different.
Yeah.
And a lot of the things we do in unstructured, we tend to use what we call regex, if you are familiar with that. If you are not, you can check it, regex 101. It's a nice web application that allows you to test your regex code. So we try to use regex to extract. What Apache Spark does very well is being able to allow you to use these data sources, connect to them nicely in the same framework. So you can connect to a table, connect to text, connect to a semi-structured JSON store. A lot of these blob storages like S3 or file storage system also store the data as just a flat file. It's not a table in a database. So you can imagine you reading a flat file that is, say, tab separated, and you have to convert it into a table nicely to process. Yeah, so those are the differences. When you get into the unstructured world, there are no guarantees. So you the nice part is that you can switch on something, and because we are dealing with big data, you can switch on your machine and be processing the data for 2 hours, only to realize that there is a null in a certain field that has stripped your code.
Okay.
So you have spent 2 hours of time and money computing only to get to that point that your code trips because you didn't account for a null. And in the same unstructured space as well, and in big data, you don't have the privilege of scanning the data or having a feel of the data that, oh, there are no empty spaces or nulls. It might be too big and too expensive to do that.
Yeah.
Yeah. Any other questions?
Okay, so there are quite a lot of questions. How many more slides we have to go? We have 15 minutes more to finish.
Okay, so we have about 3 more, I think. If I
Okay,
remember
so
right. So here, I want to, yeah.
so somebody, okay, someone want to know whether it will be played back. Yes, it will be played back. Someone wants to know the difference between the NoSQL.
Yeah, the NoSQL and SQL.
Yeah.
Yeah. So SQL is the traditional relational databases
Yeah.
with a lot of guarantees.
Yeah.
There's a lot of consistency that you either write completely or everything fails.
Okay.
Yeah. So with SQL, it's very with SQL is structured and there is a lot of discipline around writing data and retrieving data. When you go to NoSQL, the term NoSQL, some people use it to mean not only SQL.
Yeah.
Some also use it to mean non-SQL, which is not a relational database.
Yeah.
We
Yeah.
don't have the same guarantees in NoSQL.
Yeah.
Okay. These databases sort of compromise consistency so that they can be available
Yeah.
or they can scale better.
Yeah.
So when I write the data, I sometimes I don't want to. They sort of don't they store data in typical key value stores and are not very favorable to the things that you find easy doing in relational databases like joins, for example. Yeah, but they are, you can think of them as more in the semi-structured and almost unstructured data that allows us the benefit of scaling and putting data in multiple places, but being able to query all of them.
Okay.
Now, when we say NoSQL, uh, the syntax is still to a large extent SQL. If you look at databases like Cassandra,
Mm,
they are NoSQL databases.
mm,
But after you have set up the cluster and done everything, and you want to query the cluster, the language is almost like SQL. I've forgotten the name. I think it's C-SQL or something.
okay.
It's still like SQL, but it's querying it in a bit of a different way.
Right.
So example of NoSQL databases, you have MongoDB.
Mm,
They store data in some kind of a document format and feels like JSON. You
okay.
have Cassandra as well.
Okay. Let's read the last few slides quickly. We have
Okay,
13 minutes.
so here I have the use cases. You have streaming
Mm,
for IoT.
mm,
The data is definitely going to be some kind of streaming data
mm,
pumping into your system. And that use case, in terms of storage, um, you sort of fulfill it with Apache Kafka
mm,
or Amazon Kinesis or DynamoDB. These are the class of storage or processing units that this presentation calls hot,
okay.
because they are processing the data in real time
Okay.
or collecting the data in real time. There is also a bit of the slower one, what he calls cold here. You have the file systems that store data in like text files, your normal text data. You have HDFS, which is the traditional Hadoop.
Mhm.
You have S3, so I can put files in S3 and process them later. You have Amazon Glacier. This is the concept of data lakes. So you typically put data in data lakes that are the kind of data you know that you will not be accessing very often. Typically like backups
Yeah.
and those data that you think you don't need. And then uh, 10 years down the line, you have a blue sky moment and you go back to it.
Yeah.
Then you have Elasticsearch. So Elasticsearch is for text kind of data. We can do some interesting search with this kind of data. Then
Mm,
as you go higher, you have your relational database, Amazon RDS. So the decision for an architect in this space is to decide whether I am dealing with a streaming use case,
mm,
or I need a cold or I need a warm kind of data, or what kind of availability do I want to maintain
mm. So all this data
in the
is
storage
normally
space.
stored in the cloud, isn't it? Using either Google,
Yeah,
Microsoft, Azure, or something,
yes.
or,
So
or
yeah,
Amazon.
yeah, a lot of this. So this slide is one of the presentations from Amazon.
Mm,
A lot of this processing, if you don't want to have to build up your own resources or infrastructure and you want to just rent, these are the places you go to.
mm,
And most of these technologies, like Kafka, which is one of the nice streaming frameworks, they are open source.
mm,
So you just need a Linux machine and you can follow instructions to sort of install it on your Linux server and start processing data.
okay.
Yeah. Then when you go to the space of analysis, Amazon is selling its solution, Amazon ML.
Yeah.
Now we call it Sage, Amazon Sage Maker. It's just a sort of machine learning, some kind of notebook or IDE that you use to build your machine learning models.
Mm.
Then you have the interesting, you have Spark here, you have Pig, you have Hive, but most of these use cases are nicely covered by Spark.
Yeah.
So if you enter with Spark, you would eventually may not need Hive and Pig
Okay.
because they sort of Spark does it quite nicely and seamlessly. Hive and Pig were brought in the era of Hadoop
Mm-hmm.
to sort of give us a nice abstraction so that people programming against HDFS will program in an environment that is like SQL.
Mm-hmm.
So you can think of the setup for HDFS as Hadoop, Pig on top of that, and on top of Pig you have Hive,
Mm.
which exposes a nice SQL interface for you to program as if you are doing SQL. But
Yeah.
under the hood, it is doing a complex map reduce stuff.
Yeah.
Yeah, but this use case is nicely satisfied by Spark, and you may not even need to go into the Hadoop and Hive stuff if you are in Spark.
Okay.
Then the final stage is the consumption. You would understand that the consumption is not just visualizations. You could end up building an application that does prediction.
Mm-hmm.
You could end up building a phone app, for example, that recognizes images
Yeah.
and stuff like that.
Yeah.
So you can build an app, you can then visualize the output, and these are the various visualization frameworks.
Mm.
Amazon, QuickSight, Tableau. I like Tableau. It's a nice one. Then you
Yeah.
have Looker. Tableau has Tableau Public,
Yeah.
which allows you, if you have Microsoft, to just download their UI, their desktop version,
Yeah.
some kind of a desktop version that's free, but you can't save your visualizations on your machine. You have to publish it to the web in your own account. But it's quite nice to play with, and they do
Thomas
quite
said
big.
that is Power BI.
Yeah, Power BI is for Microsoft,
Yeah. I think he
and it's
likes
also
Microsoft
interesting.
because he's actually promoting a lot of the Microsoft here, talking
Yeah,
about how running on Windows and all that. Okay,
yeah,
can we go quickly? We have only 5 minutes to finish or to wrap up.
yeah. Power BI is interesting.
Mm.
Yeah, so I've just put here some learning paths. This is the Apache Spark learning path, and it's almost a repetition from the learning path I use in my video tutorial
Yeah.
in the early part of this year. So I published for Packet, Pact Publishing, and this is the learning path we use, a bit of a modified version. Then because Python is also an interesting language in the space, I'm sharing some kind of a basic learning path
Mm-hmm.
for Python as well.
Yeah.
But if you Google learning paths, you'll be amazed the different kinds of learning paths that exist.
Of course, it will not be
Mm.
the same.
Yeah, so this is just a guide. I will
Mm.
also mention that for natural language processing, the likes of Sparsy are very interesting. And deep learning, if you want to understand the concepts of deep learning, there are libraries that are softer in explaining the concepts like Keras
Mm.
and to some extent PyTorch. Um, TensorFlow now has a nice wrapper or exposure for Keras, but TensorFlow tends to be quite tricky if you are a beginner. But I know there are more clever people than me, so I'll just leave it out there that that's how it is. Now, this is the case. We are in Africa. Uh,
Yeah.
the jobs you showed us is not they are all not in Africa. How can I make the most uh, of opportunities that exist in the space? I think for a beginner or a learner, Kaggle is interesting. The reason why Kaggle is interesting is that it has the notebooks that you can use to process the data, and it's free. So you can switch on the notebook, and the data is also in the same space. The kind of notebook and machine that Google puts behind Kaggle is among the most powerful in the free notebook space.
Okay.
So you have, I think, the memory of the machine is about 5. I haven't checked recently, about 5 gig. Data storage is about 20 gig. They have now enabled you to switch on the type of
So someone is also proposing something from Microsoft. I think we
yeah,
will
it's
invite
called
someone
Azure Notebook.
to also come and present, because he's talking about CNTK
Yeah,
from
exactly.
Microsoft.
CNTK is also a neural network, yeah, library as well. I haven't tried it before, and I don't know how easy it is,
Yeah.
but
So,
it will not
so
surprise me if it is.
yeah, yeah. Your area, his area is more in Microsoft. So we'll see. Okay,
Yeah,
continue.
so Microsoft has SNTK, and all of these cloud providers are almost competing against each other to
Yeah,
get their attention.
yeah,
So whatever you find in one, you almost find a similar thing in another.
yeah.
Amazon, for instance, promotes its kind of, it has a favorite in the
Yeah.
deep learning space. Just go with the open source and popular ones, whereas you have PyTorch, you have TensorFlow, and the
Mm.
like.
So
In terms
let's
of,
yeah.
yeah,
Let's go
you
on the
have
freelancer. Okay.
yeah, your question.
Yeah, for the freelancer and entrepreneurs.
Yes, for the freelancer, there's this interesting website, Upwork, which where people post tasks and different job they want to be done by freelancers, and you can register yourself as a freelancer and bid for this kind of jobs.
Mhm.
When you bid and you get a job, you do it and you get paid for it. And I've recently learned that uh, they have enabled direct payment into bank accounts in Ghana. I
Mm.
haven't verified that, but I'm told that is now possible. In the past, they were only doing PayPal, which tend to rule out Ghana, but now they sort of do transactions into bank accounts in Ghana. So this is interesting. So if you this is particularly interesting because you don't need to be extraordinary to participate in this. Actually, you can be a freelancer on this site and use it as motivation to learn.
Yeah.
Because when you go into the deep end and somebody says, I want you to analyze this data and do this kind of prediction for me, some people find that as enough motivation to learn the new area rather than sitting by a book and learning a whole big passage uh, or the whole titles. And you can also know that you also don't need to know everything in the space.
Mm.
You just need to be general enough and specialize where you are interested in. Now, when you need additional information, you just need to know where to get it and be comfortable that when you need that information, you understand it well enough to use it. Okay, so there are other freelance websites, and I think people will suggest additional ones. Uh, I've written here that Upwork works because I know it works.
So Upwork will work on that. We'll
That's
look at it
interesting.
for people to get to know about Upwork and to also share some of their work for people to see.
Yeah.
Is it our last slide or we have one slide? Because time is up.
Yeah, the last the last slide we have what this project that I'm championing, which is the Citizen Data Science Project, with the
Okay.
goal of using data for social good and also allowing you to learn. What I find is that if you use data that is related to your environment and with a purpose, you have better motivation to learn the subject area. So it's almost like a knowledge hub that we are trying to create, but with definite outcomes that will benefit society. And I think I find it, if you want to get started and you want to get a community around you that can help you and keep you going, this is one of the areas you can sort of contribute to and join. I have the links that are interesting. We have a Slack channel and we have data sets on Kaggle and stuff like that that you can use for practice. So feel free to join the Slack channel or send me a message if you have any further questions on this one.
Yeah,
But
so for the citizens data science community that we're holding with IIPGH in Ghana, we invited members to join, and we want to make this very active and vibrant community, so we can make use of the data we have, and we can start showing some of that to the public, and who knows, we may start getting some attention in terms of jobs in the areas of data science in Ghana.
Exactly.
Because it's going to happen. It's just that it's not very. It's not very common at the moment.
Yeah. So if I'll add to that, this is going to expose a lot of use cases that people have not seen before, and it is going to help them appreciate it because it is going to be using data that they are familiar with. So
data about hospitals,
exactly.
Data,
the Parliament, Ghana State of the Nation address, for example.
Yeah. For example, we want to know how many schools in Ghana have ICT labs, how many schools are under trees, for example. We want to have information about our State of the Nation's address from, say, 1993 to now. Whether we can find any trend.
Very good, yes.
So thank you very much.
Yeah, thank you. So that's the end of my.
I want to use this opportunity to thank you for the time, and also everybody who joined us here today. This is our first webinar, and we will be running this very frequently. Those who have interest in presentations in data science can contact us. They can get in touch with either Emmanuel or myself. We encourage others to join the data science community that we are building here, and also for us to work together. So I will allow you to recap, and then I also have a message for our members, and then we can close.
Yeah, so I have also listed interesting resources at the end of the notebook, at the end of the presentation. So you have what I find interesting is the cloud notebook environment, and I've captured the ones that I find interesting. There are more. These notebook environments allow you to program easily against machines that are not yours. to keep it simply. There is also, for Apache Spark, there's the Databricks Community Edition, which is also free. It's also a notebook environment that you can start learning Apache Spark from. There are resources out there. Some of them are free and widely available. You can follow also people on Twitter and social media and stuff like that. So there are ways to get started, and this is just a listing of some interesting resources you can make use of. To conclude, we have just spoken about the field of data science and the opportunities in there. And then we try to look at the various career paths, treating it as a spectrum, from a business problem to production, where does the various profiles sit, and we looked at the technology stack so that you can understand where you best fit, and then work from there. We finally treated how you can take advantage of stuff. The most interesting one for me is the fact that you can do freelancing wherever you are. And that is very promising. The same technologies that allow us to sit in our homes and do freelancing is available to everybody in the world. Now, if we decide that we are not going to take advantage of it, I think you can predict what will happen. It's just a case of other people or other parts of the world taking advantage of this technology and making sure that even with your knowledge and skill set, you don't benefit from the gigabit economy. The economy
we cannot pretend not to be part of the gigabit economy.
Exactly. So I for me, if you don't do anything at all with this subject area, I would just say that learn it enough, okay, to participate in IIPGH outreach programs. If it is to teach SHS people, if it is to even teach JHS people to get the basic data literacy skills, you would have contributed to transforming our country in a way.
Absolutely.
Yeah. So that's the end for me.
Thank you very much. Thank you, Manuel. Thank you. Great presentation. A lot of information for us for the first one. We look forward to part 2, where we will go a bit more into the details of some of the areas that we touched on today. We encourage those who have not joined the institute yet to join. Those who have joined, but they are not members in good standing, don't have their membership ID. I encourage you to go through the process, pay your dues, be part of the institute, because some privileges that will be accorded to those who are members, you may miss it out. So we would, Emmanuel will be sharing the slides, right?
Yes, we will share the slides. If you have further questions, feel free to put them in the comment section of the video.
Will the YouTube video also be available for those who want to play back?
Yes, it will be available, yes.
Okay, so
the slide will be available. The slide will be available in the comments of the YouTube video.
All right, great.
Yeah, so everybody can access it.
Okay, all right, great. And you have other presentations that you've shared on YouTube. Can you maybe share some of the links, or look at
I have other things in the citizen data science space. I think there my interest is in getting your help in getting data into the space so that people can analyze.
Okay.
Now the space has a lot of learning paths. It will be interesting to see what the community is interested in, and we can craft very nice learning paths for people to follow and have office hours, for example. So we set aside an hour where you can ask all your difficult questions, and then we try to solve it together and stuff like that. It's just anything that will enable you to participate fully, we are ready to give it.
Yeah, okay, great. Great. Yeah. Thank you. All right.
Thank you. Nice meeting you. Next time I wish to see all the 40 people, like some kind of video. Because I know I know there are known faces in there. I wish I could see them. I miss them so much.
I'll bring them, some of them, on board next time, so they can also, you can see them.
Yeah, thank you very much.
Thank you. Thank you. Thank you all for coming. Thank you all.
Yeah, thank you for joining. We love you. And make sure you subscribe to the video channel as well.
Exactly.
So you
Please
get
do
all
subscribe.
the
Go down and subscribe.
videos we upload.
All right.